Hey everybody, this is Abhinan. I'm the current Idea Studio resident. Here's Dr. Bush, my advisor at Michigan State University, and she'll give a summary of the problem we're dealing with. She'll give a brief overview of the project.
What we're trying to do is there isn't a lot of science behind the prevention methods used for preventing decubitus ulcers. So we're looking at the factors associated with loading. So when people sit in chairs, they experience two types of loading. One, a pressure or a normal force, and then a shear force. One is perpendicular to the skin and the other is parallel to the skin and slides along the skin. So we're trying to understand the effects of loading that people experience in chairs and how those relate to blood flow or the reduction of blood flow. Because blood flow then relates to the health of the skin, and if you can't get nutrients to the skin or oxygen to the skin eventually dies, and then that becomes an ulcer. So right now there are two philosophies associated with ulcer formation. One is that they start at the skin level and they gradually go down to the bone. The other is that they start in a deep fashion near the bone and tissue damage begins there at a micro level, and then it erupts to the top of the skin and then bursts open. So we're looking at those two theories and collecting data and developing models to help better understand which one of those theories is more likely, or if they're both equally as likely.
So the first month we did the 3D model from MRI slices. We had 50 MRI slices which are 2D, and then we used Autodesk Inventor to build a 3D model out of it. And this is the model you see here. It has the skin, the muscle, bones and blood vessels of the human forearm. And in the second month we imported this 3D model from Autodesk Inventor to multiphysics simulation, and we did some deformation analysis. We applied normal and shear loads on the forearm to replicate the experiments that we did in our lab. And we found the deformations, the forces at the bone-muscle interface and all that. And we will be importing this deformation model into simulation CFD to do some fluid flow analysis, which will give us the blood flow values at different parts of the model. Like Dr. Bush mentioned, there are two theories of ulcer propagation. One is where the ulcer starts at the skin level and progresses towards the bone. The other theory states that ulcers start at the bone-muscle interface and progresses outwards. And our deformation analysis shows data to support the second theory, and our experimental analysis with the blood flow show data that support the first theory. So we have data to support both theories of ulcer propagation. This is an ongoing work, so when I go back to MSU, I will continue using Autodesk software to build models, and these models will validate the experimental work done in our lab. When I go back to MSU, I'm going to encourage all my friends to apply for the Idea Studio program, and for everyone watching the video, I encourage you to apply.